Hello students, welcome to the Department of Collegiate and Technical Education. This is session 15 of the course Water Supply Engineering in third semester of Civil Engineering program. In the previous session number 14, we learned about pipe joints, the necessity of pipe joints, the requirements of pipe joints. We also learned the type of pipe joints, that is spigot and socket joint, flanged joint, expansion joint, flexible joint, and joints for concrete pipes that are of two types, rigid joint and flexible joint. In this session, we will be learning about laying of pipelines, then testing of pipelines, and corrosion in pipelines. This corrosion, the causes, effects, and how to reduce the effect of corrosion. These are all the things we will be learning in this session. First, this is pipe laying. Pipe laying is necessary to carry the water from the source to the consumer. This pipe laying involves the planning, digging the trench, laying the pipes, connecting them, and all the fittings, testing them. This pipe laying is carried out in several steps. The first one is preparing a detailed map showing the alignment of pipelines. This detailed map also consists of already existing water supply line, sewer line, underground electric lines, telephone lines, etc. By studying this detailed map, it is possible to not disturb the existing pipelines while constructing, laying, and completing the proposed pipeline. Second step is locating the proposed alignment of the pipeline on the ground. The stakes are marked for every 30 meter along the straight line of the pipeline. If the pipeline is curved, the center line markings are done at 7.5 to 15 meter interval. The thing is, if you mark these stakes on the center line of the pipeline, they may get disturbed during laying and excavating the trenches. So, these center markings are marked at a fixed distance, fixed offsets on either right or left side of the proposed center line of the pipeline, so that even after digging the trenches, these reference points can be there. Third step is location of pipes with respect to ground surface during laying. If we are to about lay the pipes on the ground surface, the ground is properly rammed, concrete blocks are provided for support at 5 to 15 meter interval, usually around 8 meters of interval. If the pipeline crosses a waterway, a concrete column is provided immediately after the concrete block at a distance of 1.5 meter on either side of the waterway. Flanged joints are provided at 4 to 6 meter interval, and it is noted that these flanged joints should be symmetrical on either side of the supports. If we are to lay the pipe under the ground, a minimum depth of 1 meter is maintained to prevent the pipes from any impact load from the ground to transfer into them. The width of excavation is equal to diameter of pipe plus 300 to 400 mm on either side, so that the laborers can work the pipes and pipe joints. Minimum width of the excavation is 750 mm. If the water supply line is to be excavated, laid near a sewer line, a horizontal distance of 300 mm and vertical distance of 300 mm minimum is maintained. And these pipes are laid from the existing foundations at an angle of 45 degree away from the foundation. If the surveyor is present in the site, he can give the RLs real time using auto level and leveling stuff. If the work is done by manual work in a slow manner, then site rails and boning rods can be fixed, which can be used to test the gradient of the excavated trenches. Next step is preparing the bottom of the excavated trench. If the bottom of the excavated trench is of soil, and pipe is laid and water is supplied, this soil may undergo uneven settlement. To prevent this, a concrete bed of 150 mm is laid at the bottom of the trench, and gaps are provided in these concrete beds for fixing the joints. Next step is lowering of pipes into the trench. The pipes are brought to the site and stacked, and before laying them into the trench, they are cleaned from any foreign materials and laid slowly such that the pipes may not get damaged. Next step is the jointing of pipes. The jointing of pipes, as we learnt in the previous session, can either be socket and spigot joint, flanged joint, expansion joint, flexible joint, or rigid joint. The type of joint depends upon the type of pipe and the type of the project. Along with jointing the pipes, all the fittings like sluice valves, air relief valves, gate valves, all are fixed. Next step is backfilling or refilling of the trench. Once the pipes are laid, connected, the soil excavated is again backfilled. By making sure that the backfilling material does not contain any stones, boulders, or debris. The backfilling material must be fine and laid in layers of 150 to 300 mm and rammed. The finishing may be flush to the ground, or a 300 mm mound can be made for later consolidation. So these are the steps for laying the pipes. Starting from studying the detailed map and laying the pipes with respect to the ground, digging the trenches, preparing the bottom of the trench, laying the pipes, joining them, and at last backfilling the trench. Next topic is testing of pipeline after laying. The pipeline should be tested before it is open to regular service to test its intactness, any presence of any leakages, all those things. This test can be carried out by hydrostatic pressure test and leakage test. Let us learn about this hydrostatic pressure test. The hydrostatic pressure test is carried out in this manner. The hydrostatic pressure test can be carried out to entire pipeline or section of pipeline depending upon the length of the pipeline. First, the pipeline is divided into section. The lower sluice gate valve is closed and the water is allowed to enter from the upper sluice valve. Once the water fills in the pipeline, it is made sure that all the air entrapped is released from the pipeline. Then the upper sluice valve is closed and the water is allowed to stand in the section of the pipeline for few days. Then this section is connected to a test pump through a bypass valve and the test pressure is applied. The magnitude of test pressure is 0.5 Newton per mm square or maximum working pressure plus 50%, whichever is higher. Once the test pressure is reached, the pump is removed and any fall in pressure is noted. If there is no fall in pressure, then the entire pipe section is said to be in good condition. If there is any fall in pressure, then the points of leakages and water tightness of the section is rechecked. This pressure recording process is for about 24 hours and monitored and recorded at regular intervals. This period of 24 hours depends on the type of pipe and type of the project. Second test is leakage test. The leakage test is carried parallel with the pressure test. The allowable leakage formula is given by QL is equal to ND root P divided by C, where QL is the allowable leakage in centimeter cube per hour. N is the number of joints in the given section of the pipeline. D is the diameter of pipe in millimeter. P is the average test pressure in kg per centimeter square. And C is the constant. For CI pipe, this value is 3.3. This allowable leakage is checked against the actual site leakage. If the actual site leakage is less than the allowable leakage, then the section is said to be in good condition. So these two tests are conducted, that is hydrostatic pressure test and leakage test, onto the given pipeline section before opening it to the regular service. Next topic is pipe corrosion. Pipe corrosion happens due to continuous action of water and other agencies on the cast iron and steel pipe material. Due to this, the pipe surface gets disintegrated and ultimately it gets lost. This phenomenon of progressive disintegration and the loss of pipe material is termed as pipe corrosion. Pipe corrosion can either be internal or external. Internal agency is water that is flowing through the pipe may cause corrosion. External agencies are air, moisture, and the very soil with which the pipe is in contact with. If the pipe is in contact with waterlogged soil, it may increase the rate of corrosion. The image shows the action of corrosion on a pipe, disintegration of pipe material. Next up is the factors contributing to the pipe corrosion. First factor is acidity. If the carbonic acid present in the water, they increase the rate of corrosion. As the pH value goes below 7, the water is said to be acidic, contributes towards the corrosion of pipe material. Whereas the alkaline water is said to be non-corrosive in nature. Next factor contributing towards the pipe corrosion is the biological action of iron bacteria and sulfate bacteria, causing aerobic and anaerobic corrosion respectively. Next factor is chlorination. Presence of free chlorine and chloramines becomes corrosive towards the pipe material. Then electrical currents. Union of dissimilar metals that are present in the water flowing through the pipe and the earthing of electrical supply to the pipe material causes corrosion in the pipes. Mineral and organic constituents. Presence of total solids, if it is more, it leads to increase in the rate of corrosion, whereas organic constituents is termed to be non-corrosive in nature. Oxygen. Oxygen is present in both corrosive and non-corrosive water. Oxygen is not the sole reason for the corrosiveness of water. So these are all the factors which contributes towards the pipe corrosion. Next is effects of pipe corrosion. First one is the pipe corrosion may lead to the tuberculation. Tuberculation is the formation of mounds of iron oxide on the inner surface of the pipe material by the microorganisms present in the water. As the life of the pipe increases, the deposition of this iron oxide also increases, making the cross-section area of the pipe get reduced, and thereby water carrying capacity of the pipe also gets reduced. Next effect is the pipe corrosion leads to the disintegration of pipe. As is seen in the image, the corrosion leads to the removal of pipe material, making it thin day by day, ultimately causing leakage of water and the loss of pipe material. Next effect is the pipe corrosion imparts color, taste and odor to the flowing water, which makes the water unfit to drink. Of course, due to corrosion, the life of pipe will be reduced. For example, the life of cast iron pipe is around 100 years, but due to corrosion, it may get reduced to 30 to 40 years. Corroded pipes may make water dangerous for drinking. Also, the corrosion on the inner surface of the pipe makes the surface rough, causing high frictional losses. This corrosion may spread to the connections and also the fittings. So these are all the effects of pipe corrosion. Next step, now we know what you meant by pipe corrosion and effects of pipe corrosion and causes of pipe corrosion. Now it is time to understand the methods to prevent the pipe corrosion. Although in practical condition it is not possible to completely eliminate the pipe corrosion, some methods can be adopted to minimize the rate of corrosion. First method we can adopt to prevent the pipe corrosion is cathodic protection. The Fe2 plus ions from the surface of the pipe material migrates away from the surface of the pipe because pipe material acts as anode. If we make this pipe material acts as cathode, we can prevent this corrosion. The process of making the pipe material act as cathode and thereby protecting it from corrosion, we term it as cathodic protection. This can be done by connecting the pipe material to the negative pole of the DC generator and the positive pole is connected to anode metals or simply grounded. This causes lower electrical potential of the pipe, making all the electrons from the surrounding move towards the pipe material and thereby preventing the Fe2 plus ions from migrating the pipe. This cathodic protection can also be done by making the pipe in contact with anode metals such as magnesium, creating a electronic potential difference between them and making the electrons flow from anode to cathodic pipe. Second method of protecting the pipe from getting corroded is using the proper pipe material. Making iron and steel pipes in alloy with the copper, chromium and nickel, the effect of corrosion and rate of corrosion can be decreased. It is also to be noted that any impurities present in the iron steel materials while manufacturing pipe may lead to increase in corrosion. These impurities may be tin, lead, copper, etc. Care should be taken to remove these impurities so that the manufactured pipe material has best resistance against corrosion. Next method we can adopt is by providing protective linings. These protective linings to the pipe material can be done by giving a protective lining of bitumen, tar, cement mortar, zinc, etc. But the effectiveness of these protective linings depends upon the type of material and the preparation of surface of the pipe material. Next one is by treatment of water. We know that if the pH is low, the water becomes acidic and increases the rate of corrosion of the pipe. This can be reduced by increasing the pH of the water, by making it alkaline, by adding lime, chalk, etc. Once the pH increases beyond 7, the water becomes alkaline and becomes non-corrosive in nature. Then any dissolved oxygen and carbon dioxide are removed. Sodium silicate is added. By these things, we can make the water non-corrosive in nature towards the pipe. So this completes this session. In this session, we learnt about laying of pipes and the steps we have to follow to lay the pipes, and test conducted on pipeline, that is hydrostatic pressure test and leakage test, and definition of pipe corrosion, effects, causes, and at last the remedial measures we can take to reduce the corrosion. Now it's time for multiple choice questionnaire. Question number 1. For marking center line of pipeline, Stakes are driven at dash meter apart on a straight line. A 7 meter, B 30 meter, C 50 meter, D 100 meter. And the answer is 30 meter. The center lines are marked at 30 meter apart in a straight line. In a curved line, it is about 7.5 to 15 meter interval. Second question. The top of the pipe is generally kept about minimum dash meter below the road surface so as to minimize the impact loads. A 0.3 meter, B 1 meter, C 2 meter, or D 3 meter. And the answer is 1 meter. A minimum depth of 1 meter is maintained so that the pipe materials are protected from the impact loads. Question number 3. Minimum width of excavation required for laying pipes is A 300 millimeter, B 500 millimeter, C 750 millimeter, or D 1000 millimeter. And the answer is 750 millimeter. Minimum width of 750 millimeter is maintained for the width of excavation. Question number 4. The test conducted after laying pipes are 1. Leakage test, 2. Compression test, 3. Hardness test, 4. Hydrostatic pressure test. And the options are A 1 and 2 only, B 2 and 3 only, C 1 and 4 only, D 1, 2, 3 and 4. And the answer is C 1 and 4 only. The test conducted after laying pipes are leakage test and hydrostatic pressure test 1 and 4. Question number 5. Formula used to calculate allowable leakage QL is A. ND root P divided by C, B. NDC divided by root P, C. ND divided by PC, D. D root P divided by C. And the answer is A, that is ND root P divided by C. Question number 6. Corrosion of pipe may occur due to A. Action of water flowing, B. Action of natural agencies, C. Type of contact soil, D. All the above. And the answer is D. All the above. The water flowing inside the pipe, the natural agencies, contact soil, all contributes towards the corrosion of pipe. Question number 7. Factors contributing to corrosion of pipes are acidity, alkalinity, free chlorine, organic matter. Options are A. 1 and 2 only, B. 1 and 3 only, C. 2 and 4 only, or D. 1, 2, 3 and 4. And the answer is B. 1 and 3 only. Acidity and free chlorines increases the rate of corrosion, whereas alkalinity and organic matter are termed to be non-corrosive in nature. Question number 8. Pipe can be protected against corrosion by making the entire pipe act as A. Cathode, B. Anode. The answer is A. Cathode. The pipe can be protected by making it act as cathode against corrosion. Question number 9. Protective lining materials which can be used for protection of iron steel pipes against corrosion are A. Tar, B. Zinc, C. Cement mortar, D. All the above. And the answer is all the above. Tar, zinc, cement mortar, bitumen can be used to protect can be used as protective lining material for protection of iron and steel pipes. Question number 10. Corrosion is the deterioration of materials by chemical interaction with their environment. It is the definition of corrosion, whether it is A. True or B. False. And the answer is true. Corrosion is the process of deterioration of material by chemical interaction with their environment. That includes the water flowing, air, moisture, and the contact soil. So this completes this session. I would like to thank all my team members with whom's help I was able to present this session to you. Thank you all.